Isn't this weird? Right here, see, look, there's something missing. There's something missing there. Or is it? It's actually intentionally missing. There's a semicolon missing, but it's excluded on purpose. Rust has this ability with expressions. I've seen it before. I've seen this ability before in Perl, where the last statement that you provide in a function at the end will always be returned to the upper scope. Rust does this too, and it's pretty powerful, although a little confusing at initial glance. And also, kind of annoying that you have to exclude the semicolon. There's got to be a good reason. Why couldn't it just be the last statement evaluation that gets returned, semicolon or not? So just like every other language, Rust is made up of a series of statements, right? We've got a bunch of lines of code that either assign data to a variable with an expression. And expressions can be either just simple literals like integers. You can also do more math here, +1 times some other additional sort of expression there. This entire line is a statement. You have an assignment of data with an expression. Rust likes to call this variable binding. And then you can have these other kinds of expressions here. Is Rust okay with this? Rust is totally fine. You can have these benign expressions that do nothing. I mean, at least it would be, maybe Clippy will come in here and save the day in saying, what are you doing here? Do you really want to be doing this? There's nothing going on here. But the Rust compiler will let you do it. These are just expressions. This is weird too with Rust. Check it out. They let you do something that I didn't know that you could possibly do. Most languages don't let you do something like this. But Rust comes with these closures, or they call them blocks, which can also be expressions. And the neat part is they can be used as values in assignments, which means that you can define a closure with these curly braces, do some work inside that scope. It's a new scope here. So let's take a look at this. Let y equal what? What's going on here? Y is going to equal this the entire result. So you can have a series of statements with expressions, and the final evaluated expression, as long as there's no semicolon at the end, semicolon, you got to make sure that semicolon's gone, that will get returned to the upper scope and be assigned to y. That is very powerful and amazing. It goes even further, where any kind of closure statement with these blocks, any kind of block, can also be bubbled up to the final scope being assigned to a variable, including flow control, like if statements and while loops. The final result that's returned will get assigned to the which is really powerful, because you can do iterations, and you might need to be coming to like a final, like if you do a sum, if you're trying to do a sum operator, you might want to loop through, and you only really care about the final value, but you can increment over time. This is really neat. I like this. So what happens when we include a semicolon inside of a block as the final line here? Well, it will return a null essentially, right? So an empty set, right? These parentheses here. So if we compile this program, we see that z is going to equal null essentially in this point, right? Because it's got a semicolon. But if we remove it, z will be x times 2, which x is 5, which means z is 10. So it's actually got a value now because it's returning. I mean, this one little symbol is all the difference. So I would really just prefer that we could do it like this. And if you wanted to return null, you could do that. Or no, this. Here we go. You return null there. I suppose there is a benefit of performance that indicates that you want to maintain the stack data in the higher scope by excluding a semicolon, which is an indication to the compiler to use more resources and to keep data around or move data as needed. So I do get the understanding here, but couldn't we just say return? But I guess if you had return here, you're often kind of thinking maybe it's a function. So it might, the return would typically go high above all the scopes until the function scope. So you couldn't do that. Maybe like a break statement would be nice. Actually, I wonder, can you do that? Nope. You can only do that inside of a loop. What we could do is this. I'm pretty sure this'll work. Wait, really? Actually, let's check this out. Oh, it works. Look at that. All you have to do is say loop. That's not confusing. Don't worry. It's not that confusing. What happens if we exclude the semicolon? Is it going to be required this time? No, it's not. So guess what? By using break and loop, the semicolon is no longer an important symbol in this scenario.